Christy, you need to explain to the people here today why we're together in this segment today.
Well, that's a great question, Katie. And it all started with a little bit of an argument, which is which planet should we personally, the staff of Science Friday, who get to travel to other planets, as you know, where should we go to look for life? Should we go to Venus? I have no opinion here, clearly, or Mars.
Right. Because a couple of weeks ago, we got this news about phosphine being discovered in the atmosphere of Venus. And everybody in the office was like, oh my gosh. And they got so excited about it. And then this news about salty lakes on Mars came out. And people were like, oh yeah, Mars is still around. People are still looking for signs of life there.
Yeah, and as you know, I'm definitely on Team Venus. I just think it's so the reason for that is that I think it's really cool that this planet, I'm an underdog person, and I think it's really cool that this planet that's been more or less ignored by NASA for so long has had such a striking piece of evidence arise for something that we really can't explain, except possibly with the presence of a lot of little bacteria swimming around in the clouds, burping out this poisonous gas, phosphine.
Okay, but I'm just someone who doesn't really like a lot of excess hype around something that maybe doesn't deserve it. There's a reason why we started our search for life with the red planet. For one, it's much more Earth-like than Venus, which is basically a hellhole. It's 698 degrees Kelvin on the surface. Two, there's a lot of very reasonable hope for living bacterial life on Mars in places like under the polar ice caps of Mars and in these new salty lakes, which would provide like stable places for this life to be.
You make some very, very good points, but I don't know that Earth really wanted to be a part of this argument. But since you're bringing Earth into this, you know that Venus and Earth are basically twins, right? But just slightly different, more hellish conditions. Venus is hot, it's high pressure now, but it's partly because Venus had this runaway greenhouse effect till the atmosphere was literally soup, which I don't know if that sounds familiar these days or not. So what that tells me is that if we find life on Venus, we're also finding out something about a potential future that Earth could be dealing with and the kinds of life that may thrive in that future.
Okay, here's my counterpoint to that. Since Mars is similar to ancient Earth, we can also observe what climate change has done to Earth by looking for signs of ancient life on Mars in rocks, which Mars has and Venus does not have. And you cannot understand your future, Christy, unless you look and understand your past.
You know, that's some really good, that is a good point. That's really good, deep wisdom. But I'm going to give you some, Katie, which is I'm hearing a lot of fear of the unknown. I'm hearing a lot of hesitancy about trying something new. And I don't think that's a good rationale for making decisions about scientific exploration. Aren't we supposed to dive into the unknown and be excited to discover things that we can't see or explain from here? It feels too safe to be looking at Mars, honestly.
It's not necessarily safe. It's just like I'm more of a completist. So I feel like we haven't completed the job of Mars and found everything that we need to find. And in terms of, scarce resources and manpower and time and things like that NASA has, I feel like we just need to kind of wrap up our exploration of Mars before we move on to, other more quixotic projects like exploring Venus.
Katie, it's not quixotic though. The European Space Agency has a craft that's flying by Venus in like a week. I want to say almost exactly a week. So we may even have more data without having to do anything new, even sooner than we'll have anything from Mars, which by the way, Perseverance isn't even getting there till February.
Okay, well, I'm okay with, the concept of, the meme with the girlfriend and the boyfriend's looking back at the other girl. I'm like really cool with sticking with Mars, like sticking with the one, and then the other girl in that meme can be Venus. And the dude's just kind of like looking back at it, being like, hey, what's up back there? Just checking out the situation back there. But really, sticking with Mars, the one
Katie, are you calling me a distracted boyfriend?
Yes, distracted boyfriend meme. That is what the situation is. What meme is your planet like, Christy?
My plan is not like any meme, Katie, because it's complex and layered, and memes are very simple. But if you want a pop culture reference, we do have Carl Sagan on our side. He was proposing back in 1967, more than 50 years ago, that we should be considering the clouds of Venus as a potential habitat for microbial life forms. And who are we, Katie, to disagree with Carl Sagan?
Well, there might be a reason why we didn't follow Carl Sagan's advice all the way back then, but I'm just saying it's unlikely we're going to be able to, answer this question without pursuing both planets, which we're probably not going to be able to do with equal vigor and seriousness. So, the question is, do we switch tacks and learn more about the signs of life on Venus, which I'm arguing against, or do we stay the course and persevere? Get it, Christy? With Mars, which I think we should. And we're just going to have to imagine that NASA's out there listening to this debate because, we don't actually control the funding over there or have anything to do with their decision making, but we'll pretend that, they care about what we have to say.
Yeah, the stakes are pretty high, Katie. I know NASA's listening in my heart and I'm sweating a little bit.
Well, you don't need to sweat because the whole point of this conversation that we're having right now is that we need help from experts to help us make this decision because we're not experts in Mars or Venus. We're just science communicators.
Yeah, that's true. So what I'm going to propose, Katie, is that we phone a friend right now, spontaneously, and bring in some friends to help us out, actual experts.
Yeah, we've each brought a researcher to the discussion to help us argue our talking points in favor of our chosen planet. So joining me is Briony Horgan. She's an associate professor of planetary science at Purdue University. That's all the planets, because she's an expert in all the planets, and yet she's here with me to talk exclusively about how Mars is great and why we should be going there to look for life.
All right, Briony, nice to meet you. You seem pretty cool. I am going to bring in my friend, and his name is Jaime Cordova. He is a PhD student at the University of Wisconsin-Madison in genetics, but also astrobiology, and this will be important later. Stay tuned. He is also as of 2019, a solar system ambassador for NASA's Jet Propulsion Laboratory. So that's an ambassador for the solar system.
Yeah.
So I would say he is also pretty cool.
Okay, welcome both of you to the show. Thanks for talking some smack with us.
Thanks for having us.
Of course, of course. So I just want to start off this conversation by saying that, Christy and I made some pretty good, what I feel are some pretty good points in favor of both Mars or Venus. But let's start with you, Briony. What would you say, is the best reason that there might be life to seek out on Mars? Let's start with maybe that Salty Lakes research that we were talking about.
Yeah, well, so on Mars, we have a lot of evidence that there might be liquid water that's stable at or near the surface of Mars today. And that new Salty Lake study is a great example because it's a new result showing that there might be ponds of liquid water under the south polar ice cap of Mars, which could be a habitable environment that life could live in today, which is really exciting.
So how would we know, though, what would we need to kind of do to see if there was actually, if those habitats were conducive for life and if there was life actually there?
We've got to go, right? That's the we got to go and explore. So it'd be awesome to go send a drill or something to the South Polar Cap. It'd be great to go look at some of the sediments and things that are coming off of the South Polar Cap to see if there's anything there. It's something we could definitely do with the kind of technology we have today.
Okay, this is all a very good point, but I really want Jaime to stay in my corner, the Venus corner, and talk more about, we talked about this phosphine finding, which was pretty exciting, but maybe not well unpacked for everybody. So why is phosphine such an exciting possibility for Venus?
Yeah.
Especially when we're talking about the clouds.
Yeah, so the reason why is, okay, so first I'm going to clarify that, and the researchers who published the phosphine study made it really clear that the finding of phosphine does not necessarily equal the finding of life. So we haven't found life yet, that's for sure. But the reason why it's so interesting is because, at least here on Earth, the only types of chemistry that we know of that can make phosphine is either we make it in a lab or some form of anaerobic bacteria. So those are really the only two processes that we know of so far. And to be quite honest, even with anaerobic bacteria, we don't really understand the mechanism that they make phosphine. But that was really the reason why the phosphine detection was so exciting. It's possible that it could be life. It's also possible that it could be some form of unknown chemistry that we just don't understand. Now, the reason why it's so exciting is because in the clouds are actually the area, so Christy, sort of like you mentioned, the clouds are the area where we expect or we feel that life could exist there. And that's because the clouds, unlike the surface of Venus, which is really a lot like hell, the clouds of Venus are a lot more comfortable, at least to some forms of life.
See, I'm going to agree with you there, Jaime, that, you know, the surface of Venus, a lot like hell, you're not going to find any life there. And that's one of the reasons, but then there's also these clouds, which we can't see through. And that's one of the reasons why we chose Mars over choosing Venus to start our search many years ago in looking for life. So Briony, help us, help us understand this, the many times that we've gone to Mars to look for life, and what have we turned up so far there that's really promising.
Yeah, we've actually only gone to Mars once to look for modern existing life, and that was the Viking landers back in the 70s. And since then, we didn't see any obvious evidence for life because we kind of landed in a dry, dusty part of Mars that we now know maybe is in a really habitable environment. But since then, NASA has taken this totally new approach to try to understand when and where life may have existed on ancient Mars. And the when is really important because, as you mentioned before, Mars, we think, very long time ago, billions and billions of years ago, used to look a whole lot like Earth. At one point in its past, it had rivers, lakes, maybe even oceans that could have been a habitable environment where life could have lived. And so what NASA's been trying to do for the past 30 years is slowly build up a huge database of knowledge about, okay, first, was there water on ancient Mars? Yeah, we know that. The Spirit and Opportunity rovers showed us that water was present. Then, okay, were those environments habitable? Well, not just did they have water, but did they contain the building blocks of life as well? And that's what the Curiosity rover has shown us over the last 8 years on Mars. And now with the Perseverance rover, now that we know that, in fact, there were these, abundant habitable environments all over ancient Mars billions of years ago, we're actually going there to look for signs of ancient microbial life in the rocks. And so that's really what the search for life on Mars today is really about, is looking for signs of ancient life trapped in the rocks.
All right. So we're talking about ancient life. We sent all these craft looking for ancient life. But I really want to take our attention back to modern life, because that seems like where it's at with Venus. And personally, it feels to me like something living, we don't know much about dinosaurs because we are looking at fossils of them, or we are learning what we know about dinosaurs from looking at many, many fossils. But wouldn't it be better to have something in your hand that is still alive and metabolizing whatever it is metabolizing to make phosphine? And in that case, Jaime, isn't Venus overall a better candidate?
Yeah. So definitely, Venus is definitely a better overall candidate in that case. I mean, sure, Venus is hell-like, but I mean, at least it's not dead like Mars. So there's not as much. I mean, sure, you've got the salty lakes, but are you really going to be able to access those salty lakes under those poles? And I think some of the other there is some evidence. There are some models that show that Venus likely had a continuous presence of water for 2 to 3 billion years, which is enough time for life to have arisen there. Whereas opposed to Mars, and I'm going to do a little talking, and I've got my Mars squishy that I'm that I'm squeezing on. As opposed to Mars, which, as far as I understand, it really only has episodic, or had climate models only showed episodic times of water. That being said, yes, odds are is that there is a better chance for life in the clouds of, or existing life in the clouds of Venus, because the conditions are still right there for some forms of extreme life that we know of here, that we know some examples here of on Earth.
Can you actually give us the laundry list before, if we're shopping for life on anybody, what is on that list of ingredients?
So you need a source of water, which Venus admittedly does not have any, or has some water vapor in the clouds. Has some water vapor in the clouds that was detected I believe in the 80s. And because of the sulfuric acid that is in the clouds, the sulfuric acid characteristic of it is that it's very hygroscopic. So basically, it's able to water attaches to it, which means that there may be some extra water available that we're not necessarily aware of. You also need energy. So, for example, most life here on Earth, a primary source of energy here on Earth is the sun, photosynthesis. There is enough energy in the clouds of Venus that reaches the clouds of Venus that's been calculated to be roughly about the same, or if not a little bit more, than the photosynthetic energy that reaches the surface of the Earth. And then the last thing that you need would be some certain elements that are really needed by life. So schnapps, so carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And some days you need a little more schnapps than others. So you not only do you need schnapps, but also, there are other elements that are necessary. For example, iron is another element that's necessary for life. And we know that these 6 elements, or 6 or 7 elements, are present. They've been detected at least once in the clouds of Venus, but their actual abundance we know somewhat about their abundance, but their actual bioavailability. So is it actually something that's available to life? We're not totally sure yet. But that's why we need to send more missions to Venus.
All right. Well, Briony, we have some work to do in terms of tearing down this argument about Venus. So I need to ask you, I mean, how do researchers really think that they will actually find life in the clouds of Venus? I mean, how promising does this phosphine research look to you? And then also, second question, we have Perseverance coming up, and what kinds of evidence could Perseverance turn up that would make, if for those who are still, Team Venus, might tip the scales and make them Team Mars?
Yeah, well, I'll say Venus is just, I think it's so fascinating, right? I'm definitely Team Mars, and Venus is really cool. Right? And part of, I mean, Venus, I like to say it's literally shrouded in mystery, right? I mean, the atmosphere is just so dense, you really just know so little about it. We have, a little bit of data about the surface. We have radar that peek through the clouds, and that's kind of it. So, the phosphine detection is, I think, incredibly important because it tells us that there are weird things going on Venus that would be really interesting to find out. Now, is it life, right? I think there was a recent paper that just came out suggesting it could actually be from volcanism, right? From volcanoes spitting out crazy gases on Venus. So who knows, right? I'd love to go find out. But on Mars, I think it's important to think about, okay, so we're postulating this one environment on Venus, right? The clouds of Venus. But on Mars, man, we have thousands of different unique environments that have persisted over billions of years, from 4 billion years ago all the way till today. Some of these we've actually shown were present and had water present for at least millions of years. The Curiosity rover has been driving through hundreds and hundreds of meters of stacks of ancient lake muds that were deposited in this long-lived massive lake that was, almost 100 miles across. So we do know that there were these persistent environments on Mars that we know could have supported life because we found all those, the schnapps, the carbon, hydrogen, oxygen, nitrogen, and phosphorus, and organic materials in those muds. And so we know, so Mars in some way, I think it's a pretty, as far as these things go, which looking for life is very risky, right? But as far as these things go, Mars is a pretty safe bet. We know it has all the ingredients for life and the places where life could have lived. So Perseverance is building on that, right? So Perseverance is going to actually take these really amazing instruments that we're going to go look at the rocks at very high resolution and look for signs of these ancient microbes trapped in the rocks. And so, we're hoping to find things like organic molecules in layers and other kinds of shapes that would tell us that they were laid down by microbes. Like, for example, the kind of thing we would love to find is evidence of ancient microbial mats growing on the shores of a lake in Jezero Crater where we're exploring. That would be amazing. And the kinds of things we see from orbit in Jezero Crater where we're landing, we see evidence of this enormous delta that formed when this lake was present in the crater for a very long time. We see evidence of beach deposits where these microbes could have lived. And so we're hoping with Perseverance, we'll actually be able to see the details that'll tell us that, yeah, life might have lived here.
I have a question. We have a listener question that I think is a good one for Jaime. And I'm going to start with first we have a question from a listener, Sochi. So she's asking, do we have any species on Earth that could help us understand possible cloud life forms? And then hold that thought, because I also want Andrea Walker had a question that sort of is related to that. So yes.
And just before we get into all of that, we just want to say, just as a reminder, this is Science Friday. I'm Katie Feather.
And I'm Christy Taylor.
Talking to Planetary Smackdown specialists Jaime Cordova and Briony Horgan about which planet is best to look for life.
All right, and Andrea, you can go ahead and ask your question.
Oh, my question was about the atmosphere of Venus having acid in it. Why is it that couldn't be the basis of their kind of life as opposed to our kind of life here on Earth that is based on water.
So that's a great question. And I do want to front that with Jaime. You told me that Venus has a negative pH when we're talking about the acidity of Venus. So this is some serious acid.
Yes. Yeah. So the sulfuric acid, so there's a lot of sulfuric acid in the clouds. You're looking at a pH range of about negative 1.5 to 0.5, which is estimated. Admittedly, when I first started doing this Venus work, I didn't know that there was such a thing as a negative pH. So that was a surprise to me. But yeah, so yeah, they have to take on a lot of acid. Now, in terms of what to answer Xochitl's question, in terms of what sort of characteristics, or I'm sorry, if there are terrestrial bacteria that could potentially survive, there definitely are. Now, these are called extremophiles, but for the clouds of Venus, you have, so backtrack. Extremophiles are bacteria that are able to survive in extreme environments. So for example, you've got thermophiles, which like really hot environments. In fact, some thermophiles, if you take them out of hot environments, they die. You have halophiles, which love a very salty environment. And you also have some that really like acidic conditions. You also have some that enjoy really basic conditions. So we definitely know of organisms here on Earth that have that capability. The issue is that for Venus, you'd have to have something that's known as a polyextremophile. So that would be a bacteria that's able to withstand multiple extreme conditions. Now there are a couple of candidate organisms that we consider that may, for potential future studies, that we consider may potentially be a good analog of one, for example, and I'm going to butcher the name, is Acidobacillus ferrooxidans. Basically, it's a very hardy extremophile that can live in low pHs and can also live in high temperatures. So that's one example. Now, to answer Andrew's question, in terms of if there's so much sulfuric acid, is it possible that they could be using that? Yes. So the sulfuric acid, it tells us that there has to be sulfur in there somehow, right? And that there are sulfur species there in the clouds. We do know that there are some metabolisms here on Earth that some extremophiles use that use sulfur and different sulfur species to produce their energy. So I mentioned earlier photosynthesis is one way of producing energy. There's also something that's called chemosynthesis, which is essentially not necessarily using light, but using different chemical elements to gain their energy. And this is something that you would see, for example, or that we see in the hydrothermal vents at the bottom of the ocean because no sunlight reaches there.
All right, not to, I don't want to interrupt you, Jaime, but I do want to say, clearly I still feel that signs of ancient life on Mars are pretty fascinating and do qualify as like good, as good evidence and a reason why we want to be in Mars. But let's just say, for the sake of argument, that we are talking about, signs of modern life. There is something that Mars has that's equivalent to phosphine on Venus. And one of our watchers or listeners right now, David Rossiter, has a question about that.
Okay.
Hey, everybody. Thank you. We've for several years now had evidence of methane on Mars, and I understand that also could be an indication of life as well as a geological cause as well. Can you all comment on that, please?
And I'm going to throw that one to Briony first because she's my Mars teammate. So Briony, what about this methane on Mars? Could that be also a sign of modern life on Mars?
Yeah, it could. The reason why it's exciting to detect methane on Mars is because it's not stable in the Martian atmosphere over long time periods. Radiation and things will actually break it down, and it's not stable over scales. We think of 10,000 years. So the fact that we see methane today means it's being produced by something, right? And so the big question is, what is that something? It could be interactions between water at relatively high temperatures and rocks underground producing the methane, or it could actually be life living probably as well underground. And either way, that tells us that there's a potential habitable environment underground in the crust of Mars. And that's another place we've thought about looking for modern life on Mars, not just in these salty waters at the surface, but also in these probably cozy, warm environments underground. And so the methane might be telling us about those deeper environments on Mars.
Yeah,
okay.
Yeah.
Oh.
Well, Christy, I know that we're going to go to the question about how do we investigate these two planets next. And I think this is where Venus is rather weak and Mars is pretty strong in this case.
I don't know. I have a theory.
So we have yet another listener, Vladimir Pittman, who has a question about that.
You'll need to unmute yourself.
Thank you.
Oh, yep.
Yes, sir. Ma'am. About investigating Mars, I was just wondering, like you said, the capability of sending a probe there that would last long enough to provide samples, if we'd be able to return with samples, or would it be something that just collects evidence from the cloud? Do we have the capability to actually get to the surface and keep a probe there long enough to collect samples?
Sorry, so you meant Venus, correct?
Venus, yes,
Yeah.
Venus.
Thank you for that question. Yeah, and Jaime, I know like I have this theory in my head, like we can like maybe at least like send a big ladle past the clouds of Venus or something like that to like scoop up cloud stuff, awesome, as they say. But yeah. I think you had a better vision for how this would actually work.
Yeah, so I'm gonna backtrack real quick and say that there actually has been methane that's been detected at least once on Venus. Whether it's a sure result, we're not totally sure, but there has been methane that's been detected in the clouds of Venus. I'm just going to throw that out there. But to answer the question, yes, we can investigate. So we can investigate Venus in the sense that the Russians landed on the surface of Venus with the Venera probes. Most of them, I believe, the longest one that lasted was about 2 hours. But there is some technology that's currently being worked on where I believe it's called hot tech, if I'm remembering correctly. But basically what it is, it's this new technology that's able to, or new batteries, new systems that are able to last for a lot longer. And these are potentially some of the systems or some of the technology that's going to be applied for future missions to Venus, which will hopefully be happening now. And that's for the surface. In terms of the clouds, what would be really cool is if we have balloons, for example, or aerobots, which is sort of like a drone in a sense. There are some proposals for doing this. In fact, the Russians already did that with the Vega balloons I believe in the 80s. So this is known to be done, and it is known, and it's possible that we could hopefully be able to do it again. That would be ideal, at least in the sense of habitability, or coming from a habitability standpoint. I'll leave the geologists to want to do the surface. But I mean, it's still important to understand the geology because that tells us a little bit about the ancient climate of Venus. But at least for the atmosphere, it'd be cool if we can, collect samples from the aerosol samples from the clouds, and not only do that once, but also do it on a very temporal and spatial resolution, so at different latitudes and different times of the Venusian day. So that would be ideal, and yes, we can do that. To round out.
I feel like I've heard enough, Katie. What about you?
Yes, we do just need to wrap up as well, but I want to make some final arguments in favor of Mars. In one case, we definitely have ancient life on Mars. In another case, we could have even modern life on Mars. We've been investigating Mars for longer, and we know how to get there pretty easily. We've sent a lot of things there to investigate. We could even send humans there possibly in the future. And we have Perseverance on the way. So in terms of when you measure, the potential evidence that we might find with, and I very heavily weigh the feasibility of all of this, of getting there and looking for this life on Mars. I think Mars should be the winner in this case. I rest my case.
Well, I wasn't prepared to summarize my thoughts, so I'm just going to tell you what I like about Venus, which is that it's been neglected, except by, the Russians have actually sent quite a few missions to Venus, and NASA actually even has drafted like what a mission to Venus could look like. They just didn't go forward from the proof of concept. So the research is already out there, and we just need to stop doing this whole sunk cost fallacy situation and get excited about something that could really redefine how we understand life to be. I mean, and I think, Jaime, you would make the point that we don't even understand like 1% of the bacterial life on Earth. So why should we think, so why should we think we know what we're looking for in the first place?
Yeah.
I'll leave you with a question.
I think we don't understand 99%, or at least some estimates say that we don't understand 99% of bacteria on Earth. So just because we haven't found something that is absolutely exactly like something that could live in the clouds of Venus, doesn't necessarily mean that doesn't mean that it doesn't exist.
All right, and Briony, I'll give you the last word for Team Mars. Finish strong.
Well, I got to say, Mars, it's not just that modern life, it's we're really going to understand our origins, right? I mean, one of the reasons we're so excited about Perseverance and the samples we're actually going to get to bring back from that mission is that they're going to tell us about very early solar system history, about the very early, what did life look like 4 billion years ago? We don't really know, right? We don't know here on Earth because those rocks have been totally destroyed. So we're really excited about not just understanding whether or not there was life on Mars, but what can that tell us about the origin and evolution of life on Earth too? And I think that is so incredibly powerful to be able to study a planet where you can not just understand, is there life there today or was it in the past, but how does it relate back to how we came to be, which I think is really, really cool.
I think we have had some really great arguments on both sides, and we did pitch this as something where our listeners get to decide who the winner is. So hopefully everyone can see the poll that is up on their screen right now. Again, this is a you decide situation. You heard the arguments from both sides. You had a chance to ask some questions. There is a representative from NASA in a trench coat in this audience, or possibly in the room with me, I don't know. So now is the time to vote, and I'm going to let Diana and I'm going to keep talking about how great both of these planets really are. Like we shouldn't have to decide between two equally intriguing planets, even though there is a clear winner here.
Don't just listen to Christy's sympathy plea for Venus, how it's been very, it's the underdog planet. Think about all the time that we've invested in Mars, and would you abandon a project halfway through or 2/3 of the way through? No, you want to see it to its completion, and you want to be able to, know that you've really done everything that you can to possibly find life on that planet before moving on to something else, especially with something that's, very high risk, even if it may have a high reward. We should just stick with our current girlfriend instead of looking behind us at the girl that's passing us on the street.
My last point to that, Katie, is that that in that meme, the wrong girl is wearing the red dress. And what is the red planet? It is Mars. So if we're going to go with meme language here, I finally have a good rebuttal for that.
Can I have a kind little drum roll for the results, please?
I don't know if anyone can hear that, but I'm going to.
And the winner of the poll is Mars by a very slight margin. Congratulations, Team Mars.
Well, thanks everyone for listening so closely. Jaime, I'm going to ask you to say something nice about the other team, since you are the polite loser in this situation.
All right.
No one's a loser.
It's okay. I mean, unfortunately, Venus is used to being ignored. But I will say that regardless if Venus didn't win, Mars is still a really cool astrobiology target. Venus is a really awesome astrobiology target that I think we should investigate further. But I think it really, in understanding any sort of planetary body, is really useful for astrobiology. And I'll make one last plea for everyone who can still hear me, is that if we understand Venus, we can actually understand exoplanets, which we'll never be able to actually visit. So just keep that in mind.
And Briony, can you believe we did it? We pulled Mars to the finish line. We got a winner on our hands. But what would you like to say about Venus?
Well, I really am a Venus fan. I think Venus is a fascinating planet, and I really hope we get to send new missions there to try to understand what it used to be. I mean, Venus, we really have no idea what its history was. It could have been totally Earth-like a few billion years ago. And what happened? Something really dramatic happened to Venus to change it. And what does that mean for the history of life? And so I am extremely excited for what I hope are all the new missions NASA will send to Venus in the next decade.
Well, thank you guys both so much for joining us. This has been really fun. And thank you so much to our Zoom audience for participating in this poll. This was so fun. But yeah, and please join us next time when we do another one of these.
And thanks again to our guest. Jaime Cordova is a PhD student in genetics and astrobiology at the University of Wisconsin-Madison.
And
thanks for having me.
Yeah.
And Briony Horgan is an associate professor of planetary science at Purdue University.
Great. Thanks for having me. This is great.